Hello everyone, welcome to Mind is Fun Education. So last time we were doing some problems. Let's continue that and let's try to solve this problem number 3. This problem will fall under the categorization of matching problem, and specifically this problem is known as the hat problem. So there are variety of this hat problem, and one of the variety that I have brought here. Okay, first of all, let's try to read the problem, understand the problem, then we will see how we can solve this problem. So suppose n people throw their hat in a box and then each picks up one hat at random. What is the expected value of this random variable x? And this random variable x is the number of people that get back their own hat. Right? So problem statement is simple. So there are n people and they have their own hat. What they have done, they have thrown the hat into the box, right? And now they are picking at random these hats, right? So there would be possibility that they will get their own hat back, or might be they will not get their own hat back, right? So they will, since they are picking it randomly, maybe they will pick someone else's hat or someone will pick someone else's hat. But there is also the possibility that maybe he will pick his or her own hat, right? Now for this particular experiment we have this random variable x, and this random variable x is defined as number of people that get back their own hat, right? So maybe none of the person will get their own hat back, so random variable x will take the value 0. Maybe out of n people only one people will get their hat get back, so x will take the value 1, or maybe x can take the value 2, 3, 4, 5 depending on whatever the outcome has occurred at the end of the experiment. So we have to find the expected value of this random variable x. I hope the problem statement is clear. So first of all, to find the expected value of this random variable x, we should have to know about their PMF if we want to go through the formula way, right? So what's the expected value of this random variable x? That is summation over x and the PMF of this random variable x, right? But it is not easy to find the expectation using this formula for this case. What we will do, we will use the tricks that we have learned, right? So maybe we will have something where we will be breaking down these complex random variable into some of the simpler random variable, and then we will use the linearity to find the expectation, right? That is the main aim to solve this problem. Alright, now let's take, first of all, let's try to understand this problem more. Let's take n is equals to 3. So there are 3 person 1 and person 2 and person 3. So they have thrown their hat into the box, right? Now they are picking their own hat. So maybe one of the possibility that person 1 will pick the hat 2, or person 1 will pick the second person hat, or person 2 will pick the first person hat, or person 3 will pick his own hat. Let me write down here. This is the hat that person 1 has picked. So person 1 has picked the second hat or the person's 2 hat, and person 2 had picked the person 1, and 3 has picked his own hat. So this is one of the possibility, right? How many such possibility could be there? this is nothing but the permutation, right? So here we have 3, so there will be 3 factorial such permutations, right? So these are the persons. So one of the permutation, that person 1 will get back his on hat while picking, 2 will get his on hat, 3 will get his on hat, right? And one possibility could be also that 1 is getting is his on hat, or 2 is getting the 3's hat and 3 is getting the 2's hat, right? And one possibility could be this one, that first person gets the third person hat, and second one gets the his on hat, and third one gets his one. So like that we will have 6 possibilities, right? Let me write down all the possibilities that may or we could have. This is one, or maybe this is one of the possibility, right? So there are 6, 1 2 3 4 5 6, right? Now if I ask you what will be the probability that each person got his on hat, right? Each person got his on hat, each person, right? So if you look at this here, these are the total possibilities, right? And if we are saying that what's the probability, or asking that what's the probability that each person got his on hat back, so this is the favorable one, right? Here 1 is getting his on hat, 2 and 3 is also getting his on hat, right? So in general, if I am asking what's the probability that each person got his on hat, then in general it would be 1 divided by n factorial, or you can directly see from here it is nothing but 1 divided by 6, right? Or 1 divided by 3 factorial. Now let me ask another question. What's the probability that ith person gets his on hat back? Let me repeat one more time. Now this is the different question. What's the probability that ith person gets his on hat back? So let's say, for an example, what I am asking, that the probability that this xi, so let me first of all denote what is this. So I am defining one new random variable, that is xi, and it will get the value 1 when ith person get his on hat back, otherwise this will be 0 otherwise, right? So this is nothing but what I am saying, I am defining a new random variable that you can say is a Bernoulli, or you can say it is as a indicator function or whatever, right? But the core thing is that this xi will take the value 1 whenever the ith person takes or got his on hat back, or it will take the 0 if that ith person is not getting his on hat back, right? So what I am asking, that the first person gets his on hat back, so random variable in that case will take the value, what's the probability of that? So let's look at this the case of n is equals to 3, right? So these are the total possibilities, right? And these are the person sequence, you can say these are the person sequence, right? And these are the sequence of the possibilities that they can get their the hat, right? So what's the probability that first person gets his on hat back, right? So here he is getting his on hat back, here also, right? And no other is favoring, right? So these two are only that are favoring. So what will be the overall probability? So that would be 2 divided by 6, that is 1 divided by 3, right? So if I have to generalize this, that what's the probability that ith person will get his on hat back if we have total n person, right? So total there would be n factorial such permutations, and out of n factorial, n minus 1 factorial will be favoring that this the ith person gets is his on hat back, right? And this is nothing but the 1 divided by n. Now let's look at this random variable and let's try to find the what is the expected value of this random variable x, and this x is the, so this is different random variable, this is xi random variable, right? And this is the random variable x that is given in the problem. So x is the number of people, so we can say that this x is the number of people that get back their on hat, right? So you see we can write this random variable as a sum of these random variables, right? So this random variable will take the value 2 when first person has got their hat back, so 1, or second person got their hat back, so 1, or maybe other have not got their hat back. So out of this n, right? So that in that case this random variable will take the value 2. So overall point is that this random variable can be written as the sum of these random variables, right? And we have done this while finding the expectation of the binomial random variable, right? We have used the same trick for finding the expectation of the binomial random variable. We will have such n random variables, right? And now we can use the linearity property to find the expectation value. So what we have done, so overall what we have done, we have this complex random variable that is x. We have shown this complex random variable into the simpler random variable, sum of the simpler random variable, and now we are using the linearity property to find the expectation of this. So using linearity, that would be the sum of the individual expectation, right? And what are these random variables? These random variables are Bernoulli random variable, right? What's the expectation of Bernoulli random variable? That is nothing but the probability of getting success or probability of getting 1, right? So Bernoulli random variable either takes let me first of all recall you how the expected value of Bernoulli random variable is nothing but the probability of getting success, just success, or let's say probability of getting 1. So Bernoulli random variable, let's say here y, either it can take the value 1 or it can take the value 0. So these are the two possibilities. If we have to find the expected value of y, so that would be nothing but the, what are the values can take? 1 with the probability p plus 0 with the probability 1 minus p. So this term will be 0. So overall the expectation of this Bernoulli random variable is nothing but the probability of getting 1, right? So what will be this probability? So this expectation would be nothing but the probability that first person gets his hat back, right? And just now we have found what is that probability is 1 divided by n, plus again the expectation would be nothing but the probability that the second person gets his on hat back is again 1 divided by n, and similarly we have such kind of n terms, so that will be 1 n into 1 divided by n, that would be 1, right? So what's the expectation of this random variable x? That is 1. So this is the answer to your question, right? Let me know if you have any kind of doubt in the comment section, or even you can ask on the group. So let's try to find one more quantity, that is the variance of this random variable, variance of this random variable x. So let's calculate this variance of this same random variable x. I hope at this time you are comfortable with this question and how we have calculated the expected value using the linearity property of this expectation. One more point to note here, that doesn't matter this property, the linearity property of this expectation is always true. Doesn't matter that if these random variables are dependent, independent, we do not have to worry about at this point, right, for while calculating the expectation. Now coming to calculating the variance, we will have to worry if how these random variables are related to each other, right? We will have to see that if these random variables are independent, dependent, because if these so let me first of all give you the reference. So again we want to find the expectation of this variance of this random variable x, and this variance is, this random variable x is defined as number of people who got their on hat. What we have done, we have again defined another random variable for our convenient, right? And we will express this random variable x in terms of the sum of these random variable. So but here the thing is that like the expectation, we cannot say that the variance of this random variable x will be the variance of this first random variable, that is x1, plus variance of this random variable x2 plus variance of this random variable x1, and so on. Why we cannot do that? Because we don't know yet that how these x1, x2 and xn random variables are related to each other. If they would have independent, then we would have used this variance, that is the variance of this random variable x, as a sum of individual variance. But first of all, let's try to find are these two random variables are dependent or independent. Let's take an example of 2. So let's say we have 2 person, right? And what have they have done? They have thrown their hat into a box. Now let's say if I say that person 1 have picked their let's say you have this info that person 1 has got his on hat back. Can you say something about person 2's hat? Yes, if there are 2 person, if person 1 has got his on hat, then we can say simply that person 2 will also get his on hat. So point is that if you know this random variable, then you know this random variable. You are saying the dependency, right? Or maybe if I tell you that person 2 has not got back there his on hat, in that case that will also imply that person 2 will also not get their head back, right? So you can easily see for the case of n is equals to 2 that there is a dependency, that if you know the random variable about x1, then you know about the random variable x2. If you know, so in general, let's say for the case of n person, so if I tell you that n minus 1 person have got their own head back, right? So you will be able to tell about this random variable xn. So if n minus 1 person have their head back, then then obviously since you know this information, based on that you will be able to answer that yes, the ns person will also be get their head back. So overall point is that these random variables, that xi's, that is x1, x2 and xn, these are dependent. So we cannot use this property of variance, that the variance of this random variable x would be the summation of these individual variance. We will be not able to use this, right? Because if they would have the independent, then in this case we will be using this, but not now. What we can do, we can use the alternative formula or the general formula of the variance. We have seen that the variance of random variable x is equal to the expectation of this x square minus the expectation of this random variable x ka whole square. In order to find the variance of this, first of all we need to find this, and we have already found the expected value of this random variable x, that is 1. So let's first of all find this one, the expectation of x square. What is x? We can write the x in terms of the sum of these random variable, right? I hope there is no confusion on this, that how we are writing this. What will be the x square? X square, that will be the sum of the square. If we have to write this in general, so if you are not getting the idea how we can write this in general, so you can simply take the smaller case, let's say x plus x1 into x2 ka whole square. So that will be x1 square plus x2 square plus x1 x2 plus x1 x2, right? So if you see there are two, sum of the two, 1 and 2. How many terms are there? There are total 4 terms, right? And with single, that is x1 x2, how many terms are there? There are 2 terms, and there are terms which have which are coming into the pair. So the single term we can write like this, that would be summation of this xi square, and this I will go from 1 to n, right? So this part will cover this one, plus we will have the cross term product, that is of xi and xj, and important that this I and j will be such that I is not equals to j, right? So how you do that? X1 plus x2 times x1 plus x2, right? So x1 times x1, that will be x1 square, x1 times x2, x1 x2, then x2 x1 and x1 square, right? So there will be no such term where here you will have 1 2 1 2, so there will be only the cross term will be there, right? There will be no like 1 1. So you got the idea, like how I am writing this in general, right? And how many such, so how many these terms will be there? and how many such these terms will be there. We will come to this part because we will have the need of finding that how many these terms will be there and how many cross terms will be there. But let's proceed further. So now we want to find the expected of this x square. That would be nothing but the expectation of these terms. So x summation from 1 is equals to n to 9 xi square plus summation ij such that I is not equals to j, and the product of the cross terms, and we can use the linearity here, right? And that would be nothing but the expected value of this x square summation will go from I is equals to 1 to n plus summation will go I is not equals to j, expectation of this product xi xj. Right? Now what will be the expectation of this xi square? First of all, what is this random variable xi? So this random variable xi is nothing but a simple Bernoulli random variable, right? So what will be the random variable xi square? It will be again Bernoulli. Why? Because if you take the value square, you will do the square, you will do the square, what you will get again? 1 and 0. So this is again a Bernoulli random variable, right? And what's the expectation of Bernoulli random variable? It is nothing but the equal to the probability, right? So it will be again a Bernoulli random variable xi, and the probability that ith person gets, so it will be equal to the probability that the ith person gets his own head back is equal to nothing but 1 divided by n. Right? Now coming to the expectation of this. So the expectation of this random variable, that xi xj. So this product will be again a Bernoulli random variable, right? But so these xi and xj are individually the Bernoulli random variable, and the product of there is also the Bernoulli random variable, right? So this expectation, so expectation of the Bernoulli random variable would be nothing but the probability that this product, that is xi xj, takes the value 1, right? And this has to be, if this is true that the product is 1, then both xi and xj need to have the value 1. And what's the probability of that? So, and these xi xj are dependent, so the probability that xi takes the value 1 times the probability that xi takes the value 1, given this xi takes the value 1, under this condition the probability that xj takes the value 1, and so this xi takes the value 1, that means the ith person picks the hat, probability of that is 1 divided by n, times the ith person has picked their hat. So now we have total n minus 1 possibilities, and out of that jth person picks his hat, the probability of that would be 1 divided by n minus 1, right? And we have just found for one term, right? And all those have the same expectation, right? So the expectation of this random variable x1 will be 1 divided by n, or the expectation of this x1 and x2 will have this this expectation. Similarly for all the term, right, for this case the expectation would be this one, and for this case the expectation would be this one for all the term from 1 to n, right? So first of all, how many these terms will be there? So there will be n terms, right? And how many these terms will be there? So you can think like this. So if you have this x1 plus x2 times x1 plus x2, right? So how many terms will be there? There will be n square terms, right? So total would be n square, and out of this, if this term is n and total is n square, then how many terms will be this one? N square minus 1, sorry, n square minus n, or in simple terms that would be n times n minus 1, right? So what will be this summation? So that would be how many terms are there? So n terms are there times the expectation of each term is 1 divided by n, plus how many terms are there? N into n minus 1, and for each term what's the expectation? That is 1 divided by n times 1 divided by n minus 1. All these get cancelled, so 1 plus 1, that would be 2. So what you have found, the expectation of the random variable x square is 2, but what we have to find this. So this expectation is 2 minus, we have already calculated the expectation of this random variable x, that is 1. 1 square is 1, so again you will get the variance 1, right? So for this problem the expectation is 1 and also the variance is 1. Okay, that is all in this video. I hope you have learned a lot through this problem. So you see how we have this complex random variable and how we have written this complex random variable in terms of the simple random variable, and using the properties we have found these quantities, that is the variance and the expectation. So we will have more such problem, and I will be uploading more problems on our practice problem section. So if you want to have the access of that, you just need to go to the mindspan education.com, right? And also in the description you will get the link, and if you enroll, then you will have more problems to practice, right? And similarly for you can enroll for the linear algebra and for the calculus too. That is all in this video. We will have few more videos, maybe 2 or 3 on the discrete random variable, then we will move to the continuous random variable. Thank you.